Hi everybody, welcome to part 2 of this recording. I'm going to try to be a little bit faster than last time. So again, excuse me, I'm dealing with chapters 23 and I don't know if we're going to cover today chapter 24 or not, but I will try. At least we have at least two, maybe potentially three parts to this review. So anyway, I'm looking at problem 6 from page 23. So problem 6 basically says that a dentist uses a mirror to examine a tooth that is 1 centimeter in front of the mirror. So we know P is equal to 1 centimeter. So you have a tooth 1 centimeter part away from the mirror. And the image of the tooth is formed 10 centimeter behind the mirror. So the image Q is 10 centimeter behind the mirror. Therefore, it's a virtual image. Remember, mirrors can produce an image that is real in front of the mirror because that's what light is. But in this case, it's behind the mirror. Therefore, it's virtual. Determine A, the mirror's radius of curvature, and B, the magnification of the image. So again, we're going to find the focal length using this connection between the two. We have both P and Q. Therefore, we can find what F is. The focal length is just the inverse of this expression. Okay, so the focal length is going to turn out to be equal to 1 over 1 minus 1 over 10 because Q is negative inverted. Common denominator is 10 and the numerator is 10 minus 1, which is 9. When you invert it, you're going to find the focal length that is 10 over 9 centimeters. Okay, you can do the math, please. That's fine. But, you can finish the algebra. And that's important, actually. When you are in an exam environment, you shouldn't leave it as a fraction. But I'm just giving you how to get this thing going. Obviously, we want the radius of curvature. Remember, in the case of the spherical approximation, a concave mirror, in this case it is concave because of the fact that this is positive, okay, therefore it's concave, and it's true also for a convex. So both of them, you can make parabolic mirrors using cuts from a sphere where r is equal to 2f. Okay, so in this case it's going to turn out to be 2 times 10, which is 20 over 9 centimeters. It's going to be slightly over 2 centimeters. Okay, I think this problem had all the problems in this case has 3 figs, so it's going to be 2 point something. Okay, so we need to return at least 2 sig figs. And the magnification in this case, M is equal to negative Q over P, and Q is negative 10 divided by 1. Centimeter cancels out, so we're going to end up with positive 10. The image is upright. Okay, I know they don't ask, but that's in case they do. It's an erect image. Problem 7. It says in here you have a convex spherical mirror. So we know the focal length is negative. This is convex. So its focal length has a magnification of 15 centimeters. The focal length is 15 centimeters, therefore F is equal to negative 15 centimeters. Remember, this is convex, that forms only virtual images. Is to form an image 10 centimeters behind the mirror, so we know Q is equal to negative 10 centimeters. Okay, where should the object be placed? So we need P. Basically, 1 over F equals to 1 over P plus 1 over Q. Take 1 over Q to the other side, that changes sign, and flip it. So I'm doing 2 operations, hopefully you guys got it. We will find P equals to the inverse of 1 over F minus 1 over Q inverted. Okay, and P is equal to then 1 over F. F is negative 15, so negative 1 over 15, plus, because I have a minus in here and I have a minus from the Q, so it's going to be 1 over 10 inverted. The common denominator is 30, and I have to here multiply by 2, and I have to here multiply by 3, and negative 2 plus 3, that's 1, inverted, so it's going to be 30 over 1 centimeters, or 30 centimeters, okay? So that's where you need to place the object. Of course, it's positive. It's in front of the mirror, okay? You place the object in front of the mirror, the image forms behind the mirror because it's a convex mirror. it's been this way. You need to know that always P has to be positive, unless it's an image formed from another image, which can turn out to be in the other direction. So you need to take that into account. What is the magnifications? Now we have P, we had Q, so M, which is negative Q over P, and Q is negative 10 divided by 30, negative and negative become positive, and this is 1/3, again 0.333 to be repeating. The point being, in here the image shrinks by a factor of 3, okay? But it's a positive, that means it's upright. I know they don't ask in this problem, but just in case if they do ask, is the image upright or inverted? In this case, M is positive, therefore it's erect or upright. Okay? To fit the contact lens, and this is a very long problem, to fit a contact lens to a patient's eye, a chirometer can be used to measure the curvature of the cornea, the front of the surface of the eye. The instrument, this instrument places an illuminated object of known size at known distance P from the cornea, which then reflects some lights from the object, forming an image of it. The magnification M of the image is measured by using a small viewing telescope that allows a comparison of the image formed by the cornea with a second calibrated image projected into the field of view of the prism arrangement. Determine the radius of curvature of the cornea when P is equal to 30 centimeters and M is equal to 0.013. Okay, so the whole thing was just basically trying to give us P. So imagine that there is a way of placing the object which they gave us. So I'm looking at problem 8, by the way. So P is equal to 30 centimeters and M is equal to 0.013. I mean, there is another additional 0, and that's for significant figures. M has no units. From here, we can find Q, which is, by the way, M is equal to negative Q over P. From here, we can find what the image is supposed to be at negative MP. And we have M, we have P, so we know exactly what Q is. Q is equal to negative 30 times 0.013. And you can do the math in here, which is 0.39. Negative 0.39 centimeters. Okay, so that's what you're dealing with the eye, so the image has to form somewhere behind it, behind the cornea. Okay, not too far from it. This is not a huge distance. Determine the radius. So we have Q. Now we can find what F is, and from there we can find what R is. Again, 1 over F is equal to 1 over P plus 1 over Q. And 1 over P is 30, and this one is a negative number, 1 over 0.39. Obviously, the answer is going to be very close from this number because F is the inverse of this expression. This is an extremely small number. When you divide by a big number, it's going to be small. When you divide by a small number, though, it's going to be a big number. That's why the contribution is going to be very close from this one here. Obviously, you can do the common denominator, and I don't know, and then you can do what this algebra is, times, then in here it's going to be 0.39 minus 30, and you can clearly see that the numerator is roughly, of course, you have to invert this expression. The numerator is roughly 30, it's 29 with the negative sign, of course, and the numerator is 3.9, no, what is it? It doesn't matter. So here is the expression in here. It's roughly, I'm gonna put it roughly in here. Of course, you're not, if I'm doing this for an exam, I have to really be precise. So this is 30 times 0.39, and this is roughly 30 because 30 is subtract with a negative sign, of course. You subtract from it 0.39, so it's gonna be 29 and some change. This and this roughly cancel, so the answer is gonna be very close to 0.39. Not exactly, but very close from it, okay? Very close. Centimeter, okay, because that ratio is there. So please do this, okay? So you might find slightly more, and it has to be more because 30 is more than 0.29. Let's, for the sake of argument, so that we don't make it equal to Q, let's make it equal to 0.4 with a negative sign because that's how much it is, okay? So it's going to be roughly 0.4 with a negative sign. Okay, F is a negative, that means it's actually actually convex, okay? We're dealing with a mirror in here. So it's a convex mirror. And also centimeters, of course. And from here we can find R, which is going to be roughly also negative 0.8 centimeter. Okay, twice that much of F. And that's the answer to the question. Okay. The next problem is problem 37 from page 778. Of course, you guys already have the handouts. I know I have mentioned that in the part 1. If not, you need to pull out the book and go to those pages and you should have them. Okay, so problem 37, it says an object of height h equals to 8 centimeters. They didn't say h, but and we know that what the symbol we use for the height is placed 25 centimeters to the left of a converging lens. So we have P is equal to 25 centimeters to the left of a converging lens. So we know F is positive already. Okay, converging lens. And this is a lens, not a mirror. Okay, with a focal length of 10 centimeters. So F is equal to positive 10 centimeters. It's a converging lens. Determine A, the image location, B, the magnification, C, the image height, D is the image real or virtual, C, is it upright or inverted. So basically we have to answer everything in here. So, okay, first of all, we need to find Q. Remember, 1 over P plus 1 over Q is equal to 1 over F, which means that Q, after you move the 1 over P to the other side, and you change the sign for it, and then you invert, it's going to look like 1 over F minus 1 over P inverted. Okay, P then is equal to 1 over F, which is 1 over 10 minus 1 over 25, and the whole thing is inverted. The common denominator is 50, and you will have in here 5, and this is 2 inverted, so it's going to be 3, so P is equal to 50 over 3 centimeters. So it's going to be something slightly less than 17 centimeters, because 3 times 17 is 51. So this is actually going to be 16.67 centimeters, okay? 16 and 2/3 of a centimeter. So, and it's positive. Of course it's positive. P is always positive. At least the first one is positive. So the subsequent P's, they may be in a different location, but that's another thing. So we found where the image is. Sorry, Q, not P. It's Q. Q. Okay? That's how much it's supposed to be. Q, not P. Okay. So we found that. And it's positive. That means it's real. Okay, so at some point we're going to be answering. So let's find the magnification first. M is equal to negative Q over P. Obviously, you need to change this one to a decimal representation, because 50 over 3 it's a fraction, so you need to correct it. Okay, it's 16.67, I think. Remember, we have only 3 sig figs, so it's actually 16.7 centimeters. Okay, so it's going to be negative 50 over 3 divided by P, and P is 25, cancel 25 over 50, so it's going to be negative 2/3, okay? It has no units in the equation, so it shrunk by a factor of 2/3, and it's inverted because of the negative sign. Then the image's height, h prime, is going to be the absolute value of m times h, so which means 2/3 of an h, and h in the beginning was equal to 8 centimeters. So this is 16 over 3 centimeters, okay? Just slightly more than 5. Actually, it's 15 divided by 3 is 5, and you have a third. 5 and a third. So h prime is 5.33 centimeters, okay? So that's how high the image is, okay? Is the image real or virtual? This image is real, because Q is positive. Okay, it's in front of the mirror. Is this image inverted or upright? The image is upright. I mean inverted, because M is negative. M is negative, then the image is inverted. Okay, so I've answered everything. Problem 38, which is the next problem. It says in here, an object is located 20 centimeters to the left of a diverging lens. So they said that P is equal to 20 centimeters, and of course F is negative in this case because it's a diverging lens, negative 32 centimeters. Okay. Determine the location, the magnification, and the magnification of the image, and do the diagram. Okay, so let's find Q first, okay? Remember, Q is going to be equal to 1 over F minus 1 over P inverted. So that's going to be equal to 1 over negative 32 minus 1 over 20 inverted. Of course, the minus will come out, and the whole thing is going to be, of course, diverging lenses produce only virtual images, so the value is going to be negative. So the common denominator 32 and 20. What is it? 64. Okay, I'm really, let me find the GeoGebra in here. So basically at the end is going to be just 1 over 32 plus 1 over 20. Okay, let's invert it also since we're at it in here, okay? 1 over 32 plus 1 over 20, and the whole thing is, so the answer is 160 divided by 13, okay? 160 divided by 13, which is roughly equals to 12, okay? 12.3 centimeters, okay? So that's the answer, 160 divided by 13 centimeters, which is roughly negative 12.3 with the negative sign centimeters. So that's the position of the image, and the magnification M is equal to negative Q over P, and Q is actually negative 160 divided by 13 divided by P. P is equal to 20 centimeters, 20 and 160, that's 8. So it's negative 8 over 13. It has no units, slightly less than half, or more than half. Because half of 13 is 6.5. Okay, so this is more than half. Okay. I mean, you're supposed to do the algebra, okay? We can put it on GeoGebra and gonna find 0.5 or 0.6 or 0.7 or something like that. So you just can finish that part. Okay, construct the image of the diagram. Remember, we have a lens that is diverging. So if, again, in an exam, if you are going to construct, you're going to need a ruler. So I'm going to be providing rulers for you guys. So you really need to be careful when you draw this one. It has to be drawn to scale correctly, okay? So I have a lens of focal length 32. So this is 32 centimeters. And this is probably here. Maybe here somewhere. This 20 centimeters is where my object is. And here is my object. Okay? And the ray that comes parallel to the optical axis, it's as if coming from this side, and it's going to diverge this way. Okay? The ray that goes through the axis of symmetry, this ray has an incoming angle of 0 degrees. So this is ray 1, this is ray 2. Has an incoming angle of 0 degrees. And so it's, remember, this is a lens, it looks like this, okay? Diverging lens. So it's going to go through an index of refraction. So n sine 0 is equal to 1 times sine 0. So it's going to be 0. And the n at the end. So this one will go unimpeded, the other one. So this is where the image is formed, on this side of the lens. So it's virtual because of the fact that there is no light in it. It's an extension of the other ray. And this image is situated at 12.3 centimeters, okay, with a negative sign because it's on this side. And this is also negative, okay? So that's a lens. Of course, it has two focal lengths, so it's still, even though it's diverging lens, still has two focal lengths. Okay, If it was converging, then this ray will go here. But this is diverging, so the ray will go away from it. So this is problem 38. Problem 42 is a little bit complex, and I think we did something like this one in class, so hopefully you guys can pull your notes and go through this one. So what we have in here, let me just basically draw them. So we have two lenses. The first one is converging lens, and the second lens is a diverging lens. Okay, and the separation between them is given to be 10 centimeters. Okay, and the focal length of the first lens is equal to negative, the focal length of the first lens is 4 centimeters. So this distance is 4 centimeters, so this is F1 in F1. And the second lens is, so it's a 6 centimeters away, so from the other one. And the other focal length has a -8. So that means this focal length is very close from here. So this is F2, and this is F2, where F2 is negative. F2 is equal to -8 centimeters, whereas this one is -4 centimeters. Okay? So, positive. This is a focal converging lens, positive, the other one is negative. Okay? What else do we know? We have an object that is placed at -2. So this is x equals to 0 coordinate system. The object was placed in here at 2 centimeters. So this distance is 4 centimeters, but it's on this side, so I'm going to write it as -4 centimeters. So this is where my object is, okay? At 2 centimeters from this side. So P is equal to 2 centimeters for this lens, okay? It's positive because it doesn't matter. The x equals to -2 centimeters is just a reference with respect to where the origin is. What we want is the distance. Okay. So determine the position of the final image and the overall magnification. So this will form an image. It could be virtual or it could be real. Virtual on this side, real on the other side, because the ray will come in and converge to this focal length. So if there is an image forming on this side, it's from real intersection of rays. If the image was forming on this side, there is no intersection of rays. It appears to be as if there was one before rays went through the lens. Okay, so let's find where the image from the first lens is. That's going to be where the object is for the second lens. So in this case, 1 over, I'm going to write everything with an index 1. And in here, P1 is exactly 2 centimeters. So we need to find where Q1 is. Q1 from this lens is going to be the inverse of F1 minus 1 over P1 inverted. This is equal to 1/4. This one is equal to 1/2. And it's inverted. 1/4 minus 1/2 is just -1/4 because 1/2 is more. And you invert it, so Q1 is equal to -4 centimeters. Indeed, the image actually forms exactly where the focal point is. So this is where the image is. Okay, I don't know if it's more or less, that's still another question, but that's where the image is. That is where the object of the second lens is. So this is where the P2 is. Equals to this whole distance plus the 4 centimeters. Therefore, it is equal to 14 centimeters. Okay, so now if we solve for that, we're going to do the same thing. Q2, which is the final image, by the way, is equal to 1 over F2 minus 1 over Q2, and that is inverted again, 1 over -8 centimeters minus 1 over 14 centimeters. And this is inverted, the common denominator is going to, so the minus will come out, so it's going to be 1 over 8 plus 1 over 14 inverted. Of course, the image is going to be virtual. It's going to be in front of this lens, somewhere in here, okay? Maybe somewhere in here, the whole area in there, to the left, it doesn't matter, okay? So again, in this case, Q2 is going to be equals to, I'm going to get the algebra going for me, 1 over 8. 1 over 8 plus 1 over 14 and the whole, okay, it's 11, I'm going to invert it, and it's going to be 56 over 11. I mean, if I'm curious, trying to find it, 5.09, okay, 5.09, negative 56 over 11, or negative 5.09 centimeters, okay? So that's how far it is. Obviously, this places it just almost midway between these two lenses. So if this is midway, it's slightly 5.09 is closer to this lens than the other one. I'm sorry, 5.9 from this lens. So it's actually closer to this lens. Actually, we were supposed to find this distance anyway. This is where the image is, final image. And that's going to be 10 minus 5.09. Going to be, Q final in coordinate systems is 10 minus 5.09, and that should be 4.91 centimeters. So it's closer to this lens, converging lens, than the diverging lens. Because it's away from this lens is 5.09. You subtract it from 10, you're going to find it closer to this lens. It's almost midway, so it's not it's not a big deal, okay? But in case of an exam, by the way, you have to really find the exact value. It's 4.91 centimeter from the origin of the system. We don't care about what, we happen to choose the origin of the system to being the lens 1, the converging lens. Determine the overall magnification. The overall magnification, M is going to be M1 times M2, and M1 is equal to negative Q1 over P1 times negative Q2 with a negative sign inside, negative Q2 over P2. Obviously, the negative and the negative cancel, so M is going to be equal to Q1 over P1 times Q2 over P2. Okay, Q1 was negative 4, Q1 was equal to 2. No, it was 4 also, I'm sorry. No, 2, you're right. Remember, this is P1, this is Q1, negative 4 and positive 2. So that's correct. And so this is 2, okay? Times Q2, which is negative 56 over 11. Negative 56 over 11. Divided by P1. And P1 was 14 centimeters. Okay, so we should, so first of all, it's positive. And 4 times 56 over 11 times 14, so it's going to be a number in here, okay? I really don't care much, honestly. Well, you're in an exam, of course, you're going to get 4 times 56 divided by 2 from the P of the first lens times 11 from the fraction times 14 from the second P of the second lens. So it's 8 over 11 or 0.727. So it's 0.727. It has no units. It's just a number, the ratio of the height. Okay. They didn't ask anything in here. Determine its overall magnification. Of course, in here it's upright. So the first lens in here creates a virtual image that is upright, and the second lens will create an image that is still upright. So all of them, they are still upright lenses. Let me answer this person in here. Tell them that. Okay. Problem 47 from page 779. It says in here, you have an object placed 10 centimeter from a concave spherical mirror. So I have P equals to 10 centimeters, and it's concave, therefore F is positive, okay? And it's a mirror, so that you know, produces an image 8 centimeter from the mirror, okay? So we have Q is equal to 8 centimeters. A real image, that means it's positive, okay? The real image, that means Q is positive, okay? because if they tell you it's a virtual image, you have to flip the sign or the Q. If the object is moved to a distance that is 20 centimeters from the mirror, what is the position of the image, and is the final image real or virtual? Okay, I have to find F and see how F is related to the new position of the image. I mean the new position of the object. Okay, so let's do that. So first of all, F, which is 1 over P plus 1 over Q. So that means F is just the inverse of this number. Obviously, P is 10, Q is 8, inverted. The common denominator is 40, okay? So it's going to be 40 in the denominator, and in here is 4 plus 5. So it's going to be inverted, so it's going to be 40 over 9 centimeters. Okay, it's positive, okay? Therefore, it's concave. I mean, we know it's positive. It has to be, because they said specifically it's a concave mirror. Now, the thing with this is 40 over 9 is slightly more than 4. So when you place an object far away from it, it's going to be real. So at 10 centimeters, it's a real image. At 20 centimeters, it's going to be even real. It's still real, okay? In the sense that in that case, this answer to the second part is without doing calculations, it's going to be real. Let's find Q, and let's find indeed that it's a positive value, okay? Because the first part we were asked to find Q. Q again is 1 over F minus 1 over P inverted. Okay, F we just found it to be 40 over 9. So when we invert it, it's going to be 9 over 40 minus F minus 1 over P, and P is 1 over 20 centimeters, by the way, inverted. So the common denominator is 40. And here I have to leave 9 by itself, and in here I have to double that number, inverted. So the answer is going to be equal to 7 over 40 inverted. That means 40 over 7. Indeed, it's positive value, and 40 over 7 is slightly more than 5, okay? Because 7 times 5 is 35. So when this is some change, okay, 5 is some change, almost 6 actually, because 6 times 7 is 42. It's still real. Okay, that point in here, Q is positive. So the answer to the second part is it's real. Okay. Okay, let's move on. Problem 57. How many problems after that? 57. I think that's the last one, isn't it? I think that's the last one, yes. 57. 57. Okay, so problem 57 in here. It says that you have an object that is 2 centimeters high. So we're given age. It's 2 centimeters. Okay. Is placed 40 centimeters to the left of a converging lens. So we have a converging lens. That means F is positive, equals to 30 centimeters. Okay. And P for this one is equal to 40 centimeters. So the images from the get-go is going to be real, okay? Diverging lens of having focal length. So we need to label this thing. So this is F1 and this is P1, okay? We have to be careful here. Okay, so that's really the... So I have another length whose focal length is equal to negative, 20 centimeters. It's a diverging lens. Is placed 110 centimeters from the first lens. So here is a picture. So we have the first lens, which is converging lens, and we have a second lens, which is a diverging lens, and separation between them is 1 meter and 10 centimeters. So it's 110 centimeters apart. Okay. To the left of the converging. Determine the final position of the magnification of the final image. Is the image upright or inverted? Repeat the parts for this calculation by changing the second lens and now making it into a converging lens with a value that is positive 20. Okay, so right now we're working with a diverging lens. F2 is diverging, and then later on we're going to change it to a converging lens. So we have an object that is, so this is the focal length, which is 30 centimeters, and the object is just here, 40 centimeters. So this is P1. And we need to find where Q1 is. That's going to be your P2 for the second object. Okay, so Q1 is going to be equal to 1 over F1 minus 1 over P1 inverted, and F1 is 30 and P1 is 40 inverted. The common denominator is 120, okay, and in here I have to multiply it by 4, and in here I have to multiply it by 3 inverted, so it's going to be 1 over 20 inverted, so 120 centimeters. So the image from this lens is going to be at 120 centimeters. So it's going to be here, okay? So this is Q1, which is now the P2, I'm sorry, is equal to this distance from this lens. So P2 is 120 minus 110, so it's going to be 10 centimeters. That is the placement of the image, the object of the second lens. So it's situated 10 centimeters to the right of the diverging lens, okay? Since this is diverging, the image is going to be on this side still, okay? Because diverging lenses create only virtual images. So in this case, the object is on this side and the image is going to be on this side too. Okay, so let's find where the Q2 is. Q2 is going to be equal to 1 over F2 minus 1 over P2, and the whole thing is inverted. F2 happened to be negative 1 over 20 minus 1 over P2, which is 10. Remember, P2 is equal to 10 centimeters because 120 minus 110, that's 10 centimeters. This thing is inverted. Obviously, the answer, the common denominator is 20, and I will have here 1 plus 2, that's 3 inverted, okay? Which means that Q2 is equal to negative 20 over 3 centimeters, which is slightly more than 6. Actually, it's negative 6.67 centimeters, okay? Because 20 divided by 3 is 18, which is 6, and then you have 2 over 3. 18 over 3 and 2/3, which is 6.67. So the image is actually going to be here somewhere. So if this is 10 centimeters from this lens, the image is only 6.67 centimeters from this lens, slightly more than midway. So that's where the final image is, okay? So what's the first question again? Determine the final position and the magnification of the final. So we need to find M now. M is again negative Q1 over P1, that's M1, times negative Q2 over P2, that's M2. Negative Q1 was equal to 120 divided by P1, which was 40 centimeters. So that's the first magnification. Remember, 120, and the object was sitting at 40 centimeters. And Q2 is negative 20 over 3 with a negative sign, okay, the negative value, 20 over 3, divided by P1, and P1 is just 10. Okay, negative and a negative and a negative, so the M at the end is going to be a negative value. And 20 over 10, that's 2, 120 over 40, that's 3, 2 times 3, and 3 cancels the 3, so it's negative 2. Okay, so the magnification is just negative 2. It cannot be as simple as that, as this. So it's double in size, but it's inverted upside down, okay? Obviously, it should be upside down because this lens in here will create a real image, which is upside down. So the image from the first lens, which was at 10 centimeters from this lens, was here, and this will keep the orientation because it creates only real images. So at the end, the image is actually twice as big as the original object. So probably the picture is not correct. Okay, so this is tripled, but this one is just 2 times the original object, okay? So it's doubled the first object. And the size is 2, twice. But it's inverted. Inverted because of the first lens. That's the one that inverts lens. The second lens, which creates virtual images, never inverts stuff. It keeps them in the same direction, okay? Hence its value is positive in here. But the first one had a negative value, so that's why the overall is negative. Okay, so we answered the first part. The second part is said to replace the second lens by converging lens. So F2 becomes positive. So the first part of the calculation stays the same, so 120 centimeters. So it's Q2 that changes. So in the case when f2 is positive 20 centimeters, then q2 now is equal to 1 over f2 minus 1 over p2 inverted. q2 then becomes equal to 1 over, how much do you say, 20 minus 1 over 10. This one also is going to be virtual because you place an object closer than the focal length. So the image is going to be still virtual, okay? So in other words, the magnification stays negative. So let's find what Q2 is. Q2 is going to be equal to 120 minus 110, that's negative 1 over 20 because the common denominator is 20, and I will have 1 minus 2, that's negative 1 over 20 inverted. So it's going to be negative 20 centimeters. So the object, so remember the first image is 10 centimeters, the second image is going to be here, okay, somewhere in here at 20 centimeters, double this distance, and it's virtual because this is a converging lens. It's supposed to create now images on this side real, but now it created one on the same side of the object, so it's virtual, okay, just like the diverging lens did, except the diverging created closer. This one creates a little bit further, okay, so that's the only difference between the two. Now we have that, so we can find the magnification. The magnification M in this case is going to be equal to negative Q1 over P1. That doesn't change. Negative Q2 over P2, that changes. So it's equal to negative Q1. And Q1 was 120 divided by the focal length, which was, how much was it? No, P2 divided by the object position, which was 40, times negative 20 divided by P2, which was negative 10. Positive 10, I'm sorry. Always. I don't know why I put 10 here. Negative 10. It's 10. We're looking at P2. Okay. Now, this one is 2, actually. And this one... This is 20. What is 10? The position of the object is 10. The object's position is 10 centimeter. And the distance is 20. So yeah, so this is 2. And this is 3. But this is a positive and this is negative. So M at the end is equal to negative 6. So the absolute value in here has increased by a factor of 6, and it's way to the other side if you bring converging lenses. Okay, I'll stop in here, and I will see you guys for the next one. Thank you. Let me stop the recording.